So this is the last lecture on pointers. Will we first just look at what we did last time? So we actually saw how we can create a pointer to a 1D array. So what is the difference between a pointer to an integer and pointer to a 1D array? Pointer to an int and pointer to an integer 1D array. A 1D array of integers. What is the difference? The way, the syntactically, how do you define this one? What is the syntax for this? It is int star p, right? For pointer to an int. What is the syntax for declaring a pointer to an integer array of 1D integer array? It is size of the array. Suppose it is 10, then it will be this, right? If A is an array of 10 integers, A is my array of 10 integers. If I declare this pointer p, this will point to a single integer, right? So in this case, how do I assign it? I can say p is equal to a. When I say p is equal to a, I mean p is equal to address of the first element of the array. On the other hand, if I declare a pointer to an integer 1D array, then in that case, this expression is invalid. I cannot write p is equal to a. Why? Because a means address of a of 0. That means address of a single integer. This means address of a single integer. Since this is the address of a single integer, only this is a valid assignment, because this p in the case is a pointer to a single integer. This means that it is a pointer to a single integer. And if we are talking about this particular declaration, it means it can hold a pointer to an entire 1D array of integers. Okay. So if A is my array, again, so what will be the correct syntax for this? What will be the correct syntax for this assignment? Can anyone tell me? Yes? Anyone? If I want to assign this a valid value, given that A is an array of 10 integers, if I have something like this, int A of 10.
Is it ampersand a?
Yes, very good. So P is equal to address of A. This is the valid assignment for this particular pointer. And the reason is the right hand side expression means that it is address of the entire array. Okay, and that is why this is not problem. Left hand side type and right hand side type both are matching, so this is correct. Okay, so this is very important to understand. And with the help of this concept, that is pointer to a 1D array, we use the pointer to a 1D array when we discuss pointers and 2D arrays. In fact, we created a pointer to a 1D array, and we use this pointer to a 1D array with 2D arrays, if you recollect. So if my 2D array was A to D, right, like this, then in this case, what do I do? How do I use this? This one I have to use. So I say P is equal to A now, A to D. Because this is 2D, it is not a 1D array, remember. This is a 2D array. When I say P is equal to A to D, what does this mean? What is the expression on the, what is the type of the expression on the right hand side? It is an array name, right? Array name means it is the address of the first element of the array. This means this is equivalent to this, right? But when I say address of the first element of the array, this expression that I have written is nothing but the first 1D array of this, because you know that a 2D array is an array of 1D arrays, right? A 2D array is an array of 1D arrays, where the first array name will be array name of 0, right? That is first array name for this particular array. First 1D array's name is A2D of 0. Second 1D array's name is A2D of 1, and third array name is A2D of 2. These are the three arrays. These are the three 1D arrays which are the elements of this particular array A2D. Okay. So since we have written this expression, what is the type of this expression? What is the type? Again, it is a 1D array. The type is the address of a 1D array. The type of this expression is address
Yes, ma'am.
of 1D array, and that is why the expression is correct, because on the left hand side you have a pointer. This P is nothing but this. It is a pointer to a 1D array. Okay, and we saw that we derived the final expression of getting an element using the pointer notation. Yeah, right, using 1D array. What is that? If A to D is the array, so how do you get it? The element you get using this, right? This is the same as A to D ij. Yes or no? Similarly, if I want to get the address of this, I just remove this star, right? Just want to get the address of this particular element. I just want to get the address of this particular element. I remove the outside star. So this is that. This is what we discussed about pointers and 2D arrays. Okay. Next, we also saw the concept of a pointer to a pointer. What is a pointer to a pointer? If you
Double star.
want, yes, a double star. So if it is, I'm only talking in terms of integers and integer pointers, then it is a double star. So my pointer now P has become a pointer to a pointer. That means it is capable of holding what? Address of
Another pointer.
another pointer. Okay. So these are the concepts that we discuss, and you know that if I want to assign this to something, then I need to have another pointer. Okay. And this is my variable A, say. This will be pointing to A, that is, it is containing the address of A, and P will be pointing to P1. Right? This is how the assignment is done, right? And of course, we saw the dereferencing. So if you do a star star P, you will get the value of P. If you do a star P, you will get the value of P, that is address of P1, right? Then, so today what we will do is we'll take the discussion ahead and we will go with these topics which we see, that is array of pointers, pointer to a struct, and pointer to functions. One by one, we'll discuss these topics. Like you can create an array of integers. You can also create an array of pointers to an integer. Right? Array of pointers to an int. So for creating an array of integers, it will be simply int a5, right? The syntax. If you were to create an array of integers, it is simply int a5. On the other hand, if you want to create an array of integer pointers or pointer to ints, then in that case, this data type will be int star, right? This will be replaced. The type is a point. The type that I'm looking at is a point. So it means it is an array of integer pointers. Okay. Let us quickly see this example. Okay. So this is the example which is there. So I have these 5 different integers which are there with me, and I've created an array of integer pointers. Okay. How do I assign it? I know the rules of assignment. Each of these elements in this array is a pointer. That means each element is capable of holding an address, right? Each element in this array is capable of holding an address. So I say array of 0 is equal to address of V, because array of 0 is a pointer. Everyone agrees with this? Array of 0 is a pointer. Array of 1 is a pointer. That is what it means, right? The type of array of 0 is int star. The type of array of 1 is int star. Right? Type of array of 2 is int star. Are you getting it? It's a pointer to an integer. It's an array of pointers of integers. Right? So array of 0 is address of A. So you're just assigning the appropriate integers. First pointer is pointing to A, second pointer is pointing to B, and so on. If you try to print this as it is, array of 0, 1, 2, 3, 4, you will simply get the addresses of A, B, C, D, and E. Okay. How do you get the values of A, B, C, D, and E? By using the dereference operator. Right? So simply say star of array of I, and you will get the values of A, B, C, D, and E. Okay. So this is an array of pointers.
Ma'am, I just had a small doubt. In
Yeah.
the previous example, if you do star array of size equal to 10, 20, 30, 40, 50, then it will give you the value or the address.
You cannot do that. You cannot do that. You are saying here, here,
Yes, ma'am. Yes, ma'am. Yes, ma'am.
not possible,
Okay, okay.
because it can hold only addresses. It cannot hold that in those integers. When you're doing that, you have to actually uh, create these variables, and then you can have that syntax. So it has to be address of A, comma, address of B, something like that. Okay. So if I change this, right? Right? So this is the way to do it. Are you getting it?
Yes, ma'am. Understood.
Hmm. So if you look at it, it's diagrammatically it's something like this. So array is your array, ARR is your array, and you have A, B, C, D, E. Okay, and each element of array ARR actually is a pointer. So it can hold an address. It's an array of addresses basically. Okay. So there are 5 different pointers that we have. So this could be useful in several cases, like, so this is telling about how to dereference and also you have understood. I hope you have understood. Dereferencing is very easy. It's just putting the star here because it's an array of pointers. Each is a pointer. But if you want to use this, so it is used in lookup tables. If you want an index kind of a thing, so directly you will have the addresses stored in this array, and if you want to pick up something arbitrarily, you just have to look through this array, and then suppose, since these, you can see as in this example, the addresses are scattered in memory of A, B, C, D, and E. Okay, it's not an array. You have 5 different variables. So you might have such a situation where these 5 different variables are stored at different locations in real time. Okay, so in that case, you can access this using, you can create an index basically, and which is an array, which this array is going to contain addresses. So of those particular variables. So directly you can just access this array. If you want to access a particular variable, directly access the array and then get that variable's value. Okay. So that is how it works. Another example of array of pointers is when we create an array of strings. So just revisiting array of strings. You remember, right? Array of strings we had discussed. 2D array of characters. You can also write the array of strings in this fashion. Char star. So when I say char star, it is an array of, when I say it's a pointer type, right? So pointer to a character. So pointer to a character array of of 10 such characters. Okay. So in this case, when I say one particular location, I can say name pointer of I. This name pointer of I is equal to a string. Okay, so this will, what this does is this creates a constant in memory. It creates a constant string, and then the name pointer of I, it points to that particular location. Okay, it just creates a constant in memory. So is a constant that is created in memory. It is a constant which is created in memory, and then whatever is the address of that memory location, you are getting that address into name pointer of I. Okay, so this is how you're using this pointer concept with strings. So let us see the example here. So these are my strings which are created. Okay, now these are my constant strings, and if I want to actually go through these, then I can just use loop through them, and then I say the value is so and so. So just to access each string, it is names of I, names of 0, 1, 2, and 3 and 4. Okay, this is one more example with characters, character pointers. And
Ma'am, so
yes,
char star name should be an array whose elements are addresses of 5 separate characters, right?
Yes, ma'am. Same doubt.
I didn't get your question.
So, like in the program which you just showed, it had a char star name and it had strings as elements, but instead of strings as elements, it should have address of 4 different characters as its elements, right? Like in the previous example for integer pointer array, we had ampersand A, ampersand B, ampersand C. So here also we should have something similar instead of Zara, Tina, Nitin.
These are, see what happens actually, how this is implemented is Zara, Tina, Nitin and Pradeep, they are created in memory first. They are constants which are allocated memory. Okay, some arbitrary memory. And from that, those constants, what happens is the names array is given the address. The names array is given the address of that memory. That is how this works actually.
So it's same as if I assign Zara as a character array A, Tina as character array B, and then I write ampersand A, B, C. It is exactly the same thing as that. I mean, is it does it store address of Z of Zara, then address of T of Tina, like that?
Address of Z of, no, of the first location, yes.
Okay.
Yes, the first location. The first location for Zara, the first location for Tina and so on. So when you say names of I, see if you remember the pointers that we used, the 2D arrays of characters that we used earlier, we used to access each string using names of I, right?
Yes, yes.
So here also you're doing the same thing.
Okay.
So next concept is, I'll give you one more example on that. Due to shortage of time, I've not included it. I'll just give you one more example so it makes it more clear. Okay, just go through that example for that with strings. Okay, void pointer is one more concept. So we know what is a null pointer. What is a null pointer?
It points to nothing, no variable.
Yes, it is not pointing to any address. Okay, so you make sure that your pointer is null in the beginning so that you avoid the problems of uninitialization. That is the use. You also saw in files the function fopen returns a null pointer. Some of the functions return null pointer to signify an error like condition. Okay, so that could be another use of a null pointer. Now there is one concept of a void pointer. Now since void is a type that a function returns, okay, there is no type as such called void. I cannot have a variable void a, right? We can have other types, but void a, there is no type. But you can have a pointer of type void. So since you can have a pointer of type void, it must be having some special use. Okay, and the special use is that it makes it a generic pointer. Okay, it makes it a generic pointer. A void pointer is also known as a generic pointer. And a generic pointer means it can hold the address of any type. It can hold any type of address. So you can make it point to an integer, you can make it point to a float, you can make it point to a string character, and so on. Okay. So in this example, you can see that void star ptr int a is equal to 5, pointer is equal to address of a. So that pointer first you are pointing to address of a, it is allowed. Then what you're doing, you have another variable b is equal to 35.5, and you are saying pointer is equal to b. This is also allowed. So later on in your program, you can make it point to b. So how do you dereference this? How do you understand that it is a type? What it is of what type? It is your responsibility as a programmer to dereference it correctly, because for dereferencing you cannot directly dereference using the star operator. You actually need to cast it to the appropriate type and then dereference. Okay, so let us see here in the example how to dereference. So this is the same example. We created a void pointer. When I point it to a, then for dereferencing, what we do is we cast it to the appropriate type. So since it now VP is pointing to a and a is an integer, so while dereferencing, I have to make sure that I write this cast. Okay, so I first convert VP. VP is of type void. I convert it into an integer pointer. I typecast it into an integer pointer, and then I dereference it. Okay, so for dereferencing, I need to convert it into the appropriate type. Even here, I convert this, since now VP is pointing to B, I convert to a float and then dereference it. If I don't do this kind of a conversion, let's suppose I remove this, then in that case, it will not allow me to do it, because a void pointer cannot be dereferenced directly. So if I say, okay, so it says that for dereferencing, you need to cast it to appropriate type. Okay, so once I remove this, once I get it back, then I'll be able to dereference it. So I'm dereferencing A, I'm dereferencing to B. Okay, that is how I use void pointer. You should know this as a concept. We are not using this for any programs as such, but there are many cases where in the library C makes use of the void pointer, because many times what happens is when we write a function, we might want it to return a pointer or take as argument which could be of any type. It could be an integer, a float, or double. So in that case, we can make use of void pointer, because that will make it a generic function. Okay, so that is an application of void pointer. So if you go for studying data structures and the like, then you will have programs which might require void pointers. Next concept is pointer to a struct. Okay, so for pointer to a struct, you have already seen structures. You also have seen files. So in files, you write one statement. What is that statement? At the beginning, you create a pointer. What is the statement that you write in the beginning? You create a pointer, right? A special pointer.
File star.
What is that? Yes. So file star FP. What is this file star? This file star is nothing but it is a structure which is defined in the C language. Okay. It is a type def struct. Okay, it's a type def struct. So that struct keyword you do not see here. So file star. So this means it is a pointer to a struct, right? So you can have a pointer to a normal integer variable. So int star, float star. Okay, generic we saw, void star, and we can also have a pointer to a structure. Okay, so the syntax for that is type name star ptr name if you're using type defing. Okay, so if this is your type def type empty, emp underscore t is your type def type structure type that you have created, then you create a pointer using star eptr. Okay, empty star eptr. If you are using the normal way, struct m star eptr1, then in that case, and you have this variable, then in that case, what happens is eptr1 is equal to address of E. This is your structure variable E. This is your structure pointer to a struct. Star eptr1. eptr1 is a structure to a pointer, right? Structure to an employee. Sorry, pointer to an employee, pointer to a structure, right? The type of eptr1 is pointer to a structure. Okay, that means it can hold the address of an employee variable. Okay, so this is your employee variable E. So eptr1 is now holding the address of E. So this is a valid thing. Similarly, eptr can also hold EPTR that we have declared earlier, can also hold the address of E, right? Because that is also type def. You have used type def to create this type. Okay, so this is how you assign. You create the pointer, you assign it to some valid structure variable. Okay, to access the individual. Now, how do you access the individual component of the structure? You know, if it is a normal variable E, it is E dot component name, right? Employee E dot component dot operator. Now to access the individual components using a pointer via the pointer, you have this syntax star ptr name into parenthesis dot component name. Okay, so star of E dot E name. Okay, I cannot write this as this. Can I write this as this? I cannot write this because this dot is having a higher precedence than this star dereferencing operator. This dot is having a higher precedence than star. For that, you have to look at the precedence tree of, or the precedence hierarchy of C language. Okay, so this is having a higher precedence. That means this expression will be evaluated first, and then the star operation will be performed on it, which is not what you want. You want to first dereference the pointer and then get the component. So how will this expression work? It will be star of E dot E name. And what is star of E? Sorry, let me call it
Is this
EPTR. It is
employee
EPTR.
value?
Wait, it is EPTR, right? Yeah. So it will be star of address of E dot E name. Correct? EPTR is address of E. It has to be star of EPTR. Huh? Let me write this here. EPTR. This is star of EPTR. Okay. So it will be star of address of E dot E name. So this will get cancelled out. And what do you remain with? You remain with E dot E name. Okay. So that is how this is working. Similarly, for this, since it's a little complicated, the syntax, there's a shorthand notation which comes with this, and that is the arrow operator. So a hyphen followed by a greater than symbol. A hyphen followed by a greater than symbol. You can use the arrow operator with the pointer name. So it is pointer name, arrow component name. So it has to be EPTR arrow E name. Okay. This will directly be converted internally to star of EPTR dot E name. This gets converted to this expression and the rest follows. Okay. So you can use either of the two. Either you use this or you use this arrow operation. Most of the people go for this because this becomes very clean rather than writing this star of this expression. Okay. So let's see where we can use this pointer to a structure. So let us take an example for that. So if you have to create a structure called 2D point, okay, and you have to write these functions. So just you want to represent a point, xy coordinates, right, of a point using a structure. You want to write functions like this. Function for reading a 2D point, function for finding distance between 2D points. But here the question is, they have asked you to use structure pointer. Use a structure pointer for the first function, use a structure pointer for the second function. So let us see how the program is. Okay. So just create the structure point. Okay, and I've type def it. Then for reading, first function is for reading the point. So for reading the point, you simply say you are simply using a structure pointer as a parameter. So what you're doing, you're just creating a variable of type point t star, right? And how will you call this function? You're creating a variable of type point t here. In main, you're creating a variable of type point t. Okay. So P1 and P2, you want to read the 2 points from the user. One by one, you want to read the points. Okay. And then you have to find the distance of the points. Distance between the points. That is what you are required to do. So first you will read the first point. Then you will read the second. So read point is a function which will take the addresses of these variables. Okay. So what happens is, since you're passing the address here, line number 25. Here 25 and 26, you're passing the addresses of P1 and P2. What will be the type of the argument? It will be point t star. What will be the type? What is the type of this? It is point t star. Yes, because this is an address. Yes or no?
Yes, ma'am.
So this will be point t star P, and then inside this read point, you just have to be careful. Scanf, when you say scanf, it is address of that variable. Okay, so address of P arrow X, right, directly, or you can use the longer form, but it becomes a little complicated. You have to put a bracket there. That's it. So it will look little complicated. Star of P dot X will come inside. That is also valid. Okay. Here I use the arrow operator. Similarly for Y. Now, since you have passed the addresses or address of the point P, what happens now? Whatever changes you are making in this function, they are reflected to that particular variable, right? They are reflected to P1 because you are passing the address of P1. So in that memory area, in mains memory area, the changes are being made by this function read point. Are you getting it? So you do not need to return it. You remember we had written a read function earlier for some program in structures, single read function, reading a airline or something like that, not airline, the other program that we had. In that case, we were returning that variable back. What was the prototype of that function? It was returning. So if this were not a star, if this is not a star, it's a simple P point, it's a simple P type, like this, simple P type, simple variable. Then you need to return it back. You need to return it, right? Otherwise, it will not be available in main. Okay.
Yes.
In fact, we did not have this only. We had created this here. Now we had created this here, and then we returned this point T, whatever we had created it here. Yes or no? And then we use P dot X, P dot, I mean, it was another example, I don't recollect. And then we return that, return P, aise likha tha last. Yeah, and this would have been struct point T, right? So now we are using addresses, we are passing the address, we change this, right? And that is why whatever changes are made, they are being made to this memory, P1's memory. Whatever changes are being made when you pass P2, P2's memory. So this is an advantage of using pointers. Okay. Second thing is, second function is for distance. Here there is no advantage as such because you're not modifying anything. You're not modifying anything, right? But it's just telling you to use it so that you're getting acquainted with pointers to structs. So I hope you have understood how to pass pointers to structs and what is the use, how to get the components, of a structure using a pointer. Okay, using the arrow operator, that, or the star dot, that you should understand. Okay. Last concept is a pointer to a function. So a pointer to a function is basically your pointer can also hold the address of a function. The pointer so far was holding address of data that you're using in your programs, but your pointer can hold address of a function that you have in your program. So it will contain code and it will not contain data. So let us see how to create this. Let us see the syntax first. Syntax is this. You have to create, suppose you have a function in your program. Okay, this is a function which is there. This function, you want to create a pointer to this function. So to create a pointer to the function, this is the syntax. Okay. So I say the data type, whatever is the return type of this, that will come first, return type, followed by into parenthesis your pointer. So star one pointer is the name of your function pointer or pointer to a function, and whatever is the prototype of the function, that those many parameters will come here into parenthesis. So this is the declaration part. This is the declaration part, you can say. Okay, and then you initialize it. So it's basically a pointer. Remember, I cannot write this as, it is given here as a note, void star. Why this bracket is important? I cannot write this as this. Why? This bracket is important, I mean to say. This bracket which is there now, here is important. Why? Because what does this mean? This means that it is a prototype of a function which returns a void pointer. It's a normal function now which returns a void pointer.
Yes, ma'am.
So that bracket, that parenthesis is important for it to be a function pointer. Okay. So it is always it has to follow. See, it has to follow whatever function type it has to hold the address of. It has to hold the address of some function. So the prototype has to follow. So the return type followed by the function pointer name in parenthesis, followed by whatever the arguments are, whatever type of arguments and number that has to match. Okay. And this is your function pointer declared. Now you've declared this function pointer, you can initialize the function pointer in either of the two ways, like you do for your pointers also. In pointers also you can do in two ways. You can do it at the time of declaration only. So this is at the time of declaration. Here only you say it is address of fun. Now see, this is one way, and the other way is in two lines, like in this. Okay, first you declare and then you initialize. Now see, what we have done here is, this is a function. This is a function name. Okay. Now in C, just because we want to keep the way we wrote pointers earlier, that same syntax you want to continue. That is why we are using address of fun. But actually in C, a function name written directly means it is address of fun. It is interpreted, it is converted to address of the function only. This expression is converted to address of function only. So when I say address of fun, then this would be an error, right? Actually. But the compiler actually ignores it and it converts it into address. Since you are used to with using this convention, you always say na pointer equal to address of. You're used to using this address of operator. That is why you can use it. It allows you to use it. See, it allows you to use it. But both these expressions are correct. That is what I'm trying to say. If I just say void star fun pointer int equal to fun, that is also correct. Because function name written also translates to the address of the function. Okay. So this is about initializing, declaring the function pointer and initializing. Now, if you want to What is the use of it? If you're creating a pointer to a function, there has to be some use, right? So the use it is to call the function. The use of the function pointer is you using this function pointer, you can call the function. Okay, so how to call the function? Look at this. This is the function call here, right? This is the function call. You say star function pointer and you pass the argument directly. Using the function pointer name, you pass the argument. You can also write this. This also will be allowed. C will allow both syntaxes. This is your usual way. You're using star dereferencing. Okay, first one, and this is the way which makes the syntax a little neater. Actually, it makes it neater because everywhere you're using address and star, there's too much of star and address, so it becomes little. I mean, it becomes a little uncomfortable to look at. So that is why you can use this as well. So both are correct. For function call using function pointer, both this as well as this are correct. Okay, let me see. See, I have invoked it here like this. The second way that I told you, without address of operator, no address of operator directly, and this. Okay. If I run it, let me run it so that you understand how it is working. So the same function it is, basically it's just going to print the value whichever is passed. Okay, so the value of A is 10. Now this function pointer to a function can be used if you have multiple such functions in your program which are having the same data types, the same prototype basically. Only the function names are different and the functionalities are different. For example, calculator program, like a calculator. Okay, so in that case, you can make use of a function array of function pointers. You make use of an array of function pointers. This is a single function pointer that you saw, pointer to a single function. How do you convert this to an array of function pointer? What will be the change in the syntax? What do you think will be the change in the syntax? Array of function pointers.
We'll define the size after the closing parenthesis of int.
Yes. Okay. So you actually need to define the size because it's an array of function pointers. So where do you define it? This is the syntax. Okay. See, the parentheses which are there, closing parentheses, that represents the signature of the function. But since it is a function pointer, array of function pointers, that array of function pointer, that bracket is inside. Little complicated, but this is how it is written. Okay, the array bracket comes, but it comes inside. So int star fptr of 3. So that tells you it is an array of function pointers. Okay, which will point to a function with 2 arguments, integer, and return, and that function will return an integer. Yes. So for example, you have these 3, I told you, calculator program. So you have add, subtract, multiply. These are void ones. So you're printing F using printf inside a plus b, a minus b. A. You can also have integer one, a variant, where you're returning the integer. Okay. So for these functions, what is the array that you use? It is this, right? It has to match. So this void into star into bracket star fptr of array int. It has to match the signature. So see the look at the assignment is equal to add, comma, subtract, comma, multiply. Right? So that means fun ptr array of 0, that is pointing to add, of 1 is pointing to subtract, and of 2 is pointing to multiply. Okay, and then you're saying enter your choice, And based on the user's choice, I can choose. If the choice is 0, I directly call add. If the choice is 1, I call subtract. If the choice is 2, I call multiply. Okay, how do I call it? I simply pass the choice as the index while calling the function pointer. So can you see here? We are reading the choice. We read the choice, and choice we directly pass here. Okay, and of course the two values A and B you can either take from the user. Here it is hard coded, but you can take it from the user and then pass it. So accordingly, you have actually written the program for calculator here. Okay, but you have avoided using if else. Without if else or switch case, whatever you had done, without using that, you have actually written the program. So that is this is another way of writing the switch case thing using function pointers. You create an array of function pointers and then you just use the choice to your advantage. Okay, again you can remove the star here. You do not need to say this. Okay, and then there's one last concept. Let me tell that also. You can also, now we saw array of function pointers. We saw the function pointer and array of function pointers. You can also pass the function pointer as a parameter of another. It can be a parameter of some function, because in that case you can call the function through this function. You can call a function. You can pass the function in another function. You can pass a function in another function using function pointer. So that is one use. You can also return a function pointer. You can also return a function pointer from a function. Okay, that is also there. But these two things that are there, we are not going much into detail, but this is all also what you can do. You can explore this a little later. This is an advanced concept. You can explore this a little later. The examples I'll be sending to you, but this you do not have to study as part of your curriculum. You study up till only array of function pointers. That's it. How to call a function, given function using a function pointer. That is what you should know. Okay, this is there in the slide, and the examples are also there. How to return also is there, but I'm leaving it to you for self study. It is not expected as part of the curriculum. Okay, so I'll stop here. Yes, it can be used only for functions with same number of parameters. If it is a different function, same number and type as well, Siddhant. If there are different functions, then for those programs you cannot use. You will have to create separate function pointers for each type match. It has to be a separate function pointer. But for such programs, whether there are multiple functions which you have which look similar, but only the functionality is different, you can make use of that. Okay, this function pointer actually is used at the application level, where programmers make use mostly in C++ library functions which are provided. Function pointers are used. C++. Okay, so you might not be using that at this level, but later on you can explore this concept surely. That is why this concept has been introduced to you. Okay.
Ma'am, one more doubt. In the struct example, if you've got a series of dots, like how we saw in the sports club one, so to refer the base element, the last element, so you will continue using the hyphen and the greater than arrow, right? Greater than sign, continuously.
Okay, good question. So if I have if the component of this is also a structure, right? There is one component, right? You are telling this. In that case, I need to use or a union, whatever it is. Struct, some struct P, P1, okay? And P is a structure which I have defined, right? That is your question.
Yes,
So
ma'am.
in that case, I will not continue to use the dot of the arrow operator. How will I write it? So I will write it in this fashion. Suppose I want to access P1. Okay, let me write it here. Suppose I want to access P1. I will write P1 and my okay, let me use some other variable T1. And P is my function, is my structure pointer, right? This P is my structure pointer. So I will say P arrow T, okay, P arrow T, and then since T is a structure, sorry, P arrow T1, and since T1 is a structure, so T1 का structure कुछ होगा ना, sorry, T1 is a structure variable of type struct T. Suppose this is having int A, B. Okay, just an example. So I will say dot A. Dot A. Why? Because whatever I'm getting now, when I write P1 arrow T, what this expression turns into? Whatever I have passed to it. P is now actually P1. Na point P1 hai na ye. P1's address. P arrow T1 means what? How is this translated? This translates to address of star of P1 dot T. ऐसे हो जाता है T1. Yes or no? ना?
Yes, ma'am.
हाँ तो ये गया. So this becomes P1 dot T. And then dot A you require, na? Because this T that we had written, why this is important is this T1 that we wrote, na? Sorry, this is T1. This T1 that we wrote, it is not a pointer. It is a normal variable. Had this also been a pointer, अगर ये भी pointer था, struct T star T1, then you will have one more arrow there. So it will be P arrow T1 arrow A. Are you getting it?
Yes, understood.
So it has to be a dot.
When do we use hyphens instead
When
of
do
arrow?
you use?
Hyphens instead of arrow?
No. This is not the hyphen for that. This is just showing this. इसके बाद ये आया फिर ये आया. Are you getting it?
Okay, got it.
हाँ. So this kind of indirection will be useful when you actually study dynamic memory allocation and when you study data structures. So for people in IT, I think you'll be studying data structures next semester, next to next semester, third semester, second year. So there you will be revising this concept, coming back to this concept of structures. And then you will be doing dynamic memory allocation, which we are not covering as part of the syllabus. So in dynamic memory allocation, you will have such kind of constructs, structure pointers. Okay, so there arrow could be a possibility. We stop here. So all the best to you all.